Welcome back. Greetings to you. This is session 7, where we talk about machine learning techniques, some of them, not all of them, in a very simple way. For advanced knowledge in machine learning techniques, you need to actually take the follow-up courses. The audience of this session still is going to be the people who have graduated from high school or the entry-level university students. So I would like you to keep that in mind. The second thing that I would like to keep in mind all the time at the beginning, in the middle, and the end of every session and every part is that we always look at the pipeline. You collect the data, that's going to be raw data. You do the pre-processing and preparation of the data, because obviously the raw data is not necessarily easily, it's not easy to process all the time. There may be errors, there may be comma, there may be format, there may be missing components that we need to take care of. And then we may have to do some data for, transformation and data reductions that we have spoken of in the previous session. Now that the data is ready, keep in mind raw data, pre-processing, then processing, then you need to do visualization, then you need to make decisions and guidelines and policies and everything else. This pipeline, we need you to maintain that, that frame of actions in your mind all the time. Where are we? We spoke of raw data. We spoke of pre-processing, preparation of data. Now we are going to talk about the processing the data itself. We are not going to go into too complex techniques. Once again, the idea is we want to just touch them, explain them in simple terms, explain them using simple tools such as Excel, Excel file, Excel sheet, and then we want you to get the juice of the material, juice of the knowledge, and then move on to the next stage. And when we finish everything as said, for example, visualization and making decisions, you are going to go ahead and you say, I am interested in data scientist, data science program. I want to advance my knowledge. I want to go and get better knowledge about data preparation. Go for it. Better knowledge for, better education for processing, go for it. Better education for visualization, go for it. Better basically education and training for making decisions. All of these are going to be extended version of this course. So this is just the foundational course. With that in mind, I would like to start my session today. Excuse me. So let me share my screen. This is session 7, that's topic 4, predictive modeling and classification. So let's take a look at the content that we would potentially want to discuss in this session. We want to introduce you to predictive models. Decision tree is going to get a good chunk of the recording materials here. Bayesian classifier is very important. Neural network is the buzzword around. We're going to go through them, and then we're going to go to K nearest neighborhood. We spoke of that in the past. Support vector machine. This is rather a little bit advanced. I actually had the materials, but I cut them down because the intention was for the audience that are supposed to be getting to know what SVM and everything else is going to be. So for you to get better knowledge of SVM, you actually need to go and take the follow-up courses. Regression, we have spoken of regression in the past. Bagging, boosting, ADA boost, random forest. We briefly talk about them in this recorded sessions. And then we are going to actually go through evaluation. How do you know that your models are actually going to be successful? You need to evaluate the model. You need to see whether the model has been delivering what you have been expecting to some degrees. Nothing is going to be 100% success. Nothing is going to be even 95% success most of the time. As long as you know how to evaluate the model and where the model lands, that's what we want to do in this section. Confusion matrix, ROC curve, overfitting, underfitting. We have spoken of it in the past. We will be talking about it as well very briefly again. Cross-validation, very important topic. As a matter of fact, this could be half of a course by itself in future courses you will be taking. And forecasting is by itself 2 or 3 courses anyway. So I hope you agree with me that we are trying to we are trying to just touch the base. We are not going to go deep into this material, and hopefully in the follow-up recording for other classes and courses, I would be happy to deliver on details of this SVM and evaluation materials. What we are going to do in this session: decision tree, Bayesian classifier, neural network, KNN, support vector machine, a little bit, combined classifiers, for example, rainforest, and then evaluation. Let's begin part 1 of session 7, basic concepts. So let's see what it is. Now, basically what we are going to do, we are going to go through the different predictive models. There are things that we would like to do. For example, we want to understand what is happening in terms of a stock market value in future. When we say future, it means any time after what we label as today, at the present time. We want to know what the revenue of the company is going to be based on the data available to the company. For example, the number of units that are going to be coming on board, the number of iPhones that the Apple is going to have at its hand, and then basically many other factors involved, the marketing, for example, the geographical distributions of income and everything else. They are going to say, okay, what kind of projection we have in terms of sales of iPhone. It is very customary in financial sector that you are going to look at the predicted labor market number, predicted. You are going to be looking at the predicted earnings of companies. And for predicting earnings of companies is actually a science by itself. There is a huge pool of tools available, sampling and all that, so that you can actually see what the Q1, Q2, quarter 1, quarter 2, quarter 3, quarter 4 revenues are going to be for Apple or any other companies. Are they going to deliver or not? So you could potentially take a look at the news. You could potentially take a look at the transportation from Far East and manufacturing units, assembly lines to destinations, wherever it may be, to Europe, to America, to Africa. And you are going to say, okay, the transportation has been disrupted. And that's going to have a huge impact. You could potentially even correlate that with the oil price. So prediction means tell me what you could potentially identify as upcoming numbers in terms of earnings or anything else. You could potentially predict an incoming data set. So the data set is coming in. It's not perfectly reflected in the data set you already have. The data set is coming. For example, I have a case where I know that people have played tennis outside based on the humidity, based on whether it's going to be sunny or cloudy, based on the temperature, based on a number of factors. I already have a perfect data set, and this data set, everything is there, right? And suddenly a data point comes in that is a combination of what is inside the data set, but it's not exactly as in one row, one combined data set. Maybe in the past, we didn't even have an occurrence of a high temperature and a hurricane warning. We never had that in the data set. The question is, if you have a hurricane warning and you have a temperature that is rising, will you go outside and play tennis? So this could potentially be basically looking at a data set that is upcoming data set, and you're going to say and map it onto available data set. And based on what you know already, and that knowledge hopefully is going to be good enough for you to tell me whether with the warning of a hurricane, which is 200 miles from now, as well as the temperature that is here, will you be playing tennis? So that's what this one is. So predictive modeling is basically, and machine learning are actually intervened. So they are actually related quite heavily together. Now, before I go, there are many things that I would encourage you to think of as a real life example. For example, if I ask you to go to a class, the class that we have, say, for example, 10 a.m. on Tuesday morning, and you do that all the time. You go to room A, building B, and you go there at 10 a.m. This has been happening in the months of September, in the months of October, and you would know that in November you will go to the class is going to be room A, building B, and the class is going to happen at 10 a.m. So that's quite perfectly fine. You actually predicted the future with 100% certainty to some degrees. Of course, there are some issues. Maybe the university is closed either for holidays or for emergency reasons. Maybe the instructor has some fever and he's not going to show up and is going to cancel the class. Maybe you have yourself some fever and you can't attend the class because of COVID-19. And someone has contracted the COVID-19, the entire class is supposed to be quarantined. Everybody has to stay home, and we will do the class on Zoom. But at the same time, although there are some uncertainties, you could potentially say, listen, in November, I'm going to go to a class 10 a.m. Tuesday, room A, building B. So far, so good? That's one way of looking at it. This is more or so a supervised approach. A supervised approach because the university has announced it, the instructor has announced it, you can find it on your learning platform, LMS system, learning management system that you have, depending on where your organization is. It is actually set in a stone. There are uncertainties, but it is there, and you have learned it. You have done it in the months of September. You have already got used to it, to wake up at 8 a.m. and have your breakfast and then go to 10 a.m. class. And then you have the pleasure of attending the class at 10 a.m. Tuesday, room A and building B. That's supervised. Everybody told you, you learned it, everything is clear cut. There are times that it is not going to be as clear cut as you can imagine. You are going to go and buy a property, for example. Imagine you have had one house, or maybe even renting a house or an apartment. You have been renting, that's a better example for students, I would say. You have been renting for a particular university, particular city, and you have rented in your first term, you have rented in the second term, perhaps the first year and the second year. You have been dealing with so many roommates. You have been dealing with so many landlords. You have been dealing with so many situations, such as the transportation using the bus, or transportation using the car, the parking and all that. I want to put you in that scenario, in that environment for a moment. You have had collection of so much and so many data points that is coming at you. You do have some basic understanding of what the rental unit is supposed to be, in terms of facilities, internet, fridge, space, light. And then you have a basic knowledge of what the roommate is supposed to be, the type of time sharing, evening, who is going to work at the middle of the night, who is going to play music in a shared room, right? I want you to keep that in mind. I want to put you in that environment. Now you are in the third year. You have learned so much. You have learned so much by experience. Then you are going to go into the third year, and into the third year, you want to rent another unit. Now you have learned some, but you are facing an unknown territory now. You never met the landlord before. You have never rented in that specific segment of the city. And you haven't, you have perhaps a combination of equipments in that room that you're about to rent, that it is quite different than the equipment you have. Maybe in the new apartment you're going to rent, you actually have a centralized unit where you have a gym, you have a swimming pool, you have a coffee room and a coffee table and a coffee sofa and everything else. This is a different environment. You have never been in that environment. What do you make of it? Supervised you learned in the past, so that's part of the rule book you have, and you're facing a new environment, and in that new environment you need to make a decision. You are going to take a look at the new environment. There are some similarities between the new environment, the new room you want to rent, versus the many rooms you have rented in the past. Those similarities and dissimilarities are going to help you to make a decision. We are by nature human beings who would like to make decisions based on similarities. If the environment I'm going to go in, if the place I'm going to rent is similar to the place or close to the places I have rented in the past, I like similarities. I want to have some sort of predictabilities. I'm going to have a roommate, and I have met this a number of roommates in the past. I want to see whether this roommate is going to be good for me. I want to maximize the similarities of the upcoming room, upcoming landlord, upcoming roommate to what I have already known as good experience. And I want to distance myself. I'm doing a classification. And I want to distance myself from situations that are not as much similar and known to me as it has been in the past. Maybe this area of the city is not really secure for whatever reason it is. Too much traffic, too much accident, too much incidences. And you feel that this area is not safe to stay. And that's going to be the backbone of your decision. You want to be in an area that looks similar to what you have seen in the past. Unless you are a risk taker, you don't want to go into an area that you have never been before. That's what we are going to talk about. I want to put you in that environment. Now, imagine renting is over, education is over. So that was kind of semi-supervised, partly supervised, partly is not, and we have something to do in a moment. And there are times that you finish the education, you have done a lot of renting and a lot of roommates and everything else, you got a good job. And you decided renting is enough. Enough is enough. You want to buy a house, and you have never bought a house in the past. And you want to go and buy a house based on some of the experiences you have had. This is a brand new task I'm talking about. You have never bought a house in the past. You rented, you did whatever it is, but those experiences do not apply because you don't have a roommate now. Maybe you have a partner, but you don't have a roommate anymore. Roommate is temporary, but you have a partner, you could potentially be living together for a lifeline, for a long time in life. Or maybe you want to just buy it as yourself and you don't want to be even dealing with any partner anyway. You go and you see a house. You take a look at, you have seen many houses, by the way, and then you're going to take a look at the house and you're going to say, my gut feeling says this is the right house for me. You simply say, my gut feeling says this is the right house for me. And you are relying on your own internal clock and internal compass, and you are making a decision whether to buy that house for the first time. You never know. Maybe you made a mistake. After you bought it, you may have a regret or two. Then you will possibly sell it and you go somewhere else. I'm just trying to tell you there are, you have actually faced predictions a lot in your life. You have had to make decisions. We are going to talk about decision tree as one of the significant tools at our disposal for the machine learning techniques, a very effective techniques. And when we talk about decision tree has been there everywhere. You make a decision, you actually make according to a decision tree. You don't draw them on a piece of a paper. You don't have them formally shown somewhere, but you really do it in your mind. You say, if this, I'll do that. If that, I'll do this. That's a decision tree you're going to make. And decision tree is actually part of human function. You always do decision. What if I take this course? What happens to the next course? If I take this course and I fail, what happens? If I take this course and I succeed, what happens? I want to have a program in my mind. I have a kind of a chart in my mind, curriculum charts. And I need to actually finish these. These are mandatory courses that I need to take, and these are elective courses that I need to take. And elective courses give you opportunity to choose some of the possibilities. And of course, you want to see which one is going to get you the best, basically, outcome for the buck that you are going to put into the system. So selecting the courses you want to have, selecting the instructors you're going to work with, these are decision-making, basically, processes that you actually do that, decision tree. So with that in mind, let's begin. Again, the way humans work and the way computers work are quite different. Take a look at this. I want you to imagine that you have been able to use different fonts, different font types, different font size, I would say, bold or not, italic or otherwise. And this is a bag. There is a bag, and the bag is A and B and A. By the way, I'm human, you're human. You take a look at this, you see what I mean. This is a bag of words, but computer doesn't even understand that this is a bag of words. The main thing that I want you to take away from this class, by the time you finish all of my series, is that I want you to understand who the human part of the data scientist is and who the computer part of the data scientist is. These two have to have a balance. We have spoken of that in the past. There is a computer and there is a human. All the time, you need to be able to separate yourself from the computer, and at the same time, you need to know your contributions to the computer to make that decision. So what am I going to do? I have a bag of words. I said words, bag of items. Let's call it items because that's what the computer knows. And then I want to separate these letters into two categories, category A and category B. In category A, I'm going to have all of the letters that are A in different font, italic, and so on, and then Times Roman and so on. And then I have all of the letters that are going to be in B. If I succeed in separating the items in the bag into two sub-items, again, I'm trying to avoid using the word, well understood human word, I would say, let's call them items. So this item is here and this item is here, A and B. If you can make the perfect set, category A and category B, and there is nothing here that is going to be mistaken as B, and there is nothing here that is going to be mistaken as A, we are going to call them pure. This is pure A. This is pure B. And purity and impurity is the subject of this lecture series. Now, if you take a look at my face, for example, you can see I have a dot on my face, for example, right? I have a dot in my cheek, for example, right? That means my face is not pure. My heart is pure. I am a pure person, but my face is not pure, right? So when I say pure, I mean it's going to be all of that is going to be A, and all of that is going to be B. It would be a perfect outcome if I could have pure categories. But the problem is we are dealing with computers, and even humans may make mistakes. Computer more so, depending on what you tell them to do. And there will be something like A here and a little bit B and B here, and then all B, 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 and then one A and A. Therefore, you're going to have impure sets. These are going to be impure sets. So we want to recognize complex patterns and make intelligent decisions based on the data patterns. A typical machine learning is to find a model that uses that uses the automatically recognizing handwriting numbers or any text learning from a set of examples. So from a set of items in a bag. So this is what it is. So this is what we want to do. We want to tell the machine to separate. And we would be happy if the separation is perfect and the separation is pure. So I want you to keep the word pure in mind as I'm going to go and talk about the next topic in a moment. In a supervised learning, we basically talk about classification, and they are actually quite close in terms of content and meaning. Supervised learning and classifications are hand in hand, and we're going to talk about classification in a moment. And then the supervision in the learning comes from the labeled examples in the training data set. So I'm going to go back and I'm going to tell the computer, listen, this is called A, this is called A, this is called A, this is called B, 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 and then the computer has a label. When take a look at YouTube, you have lots of clips on YouTube, and I'm going to say that this YouTube is going to be about data science course, or this YouTube is going to be about climate change. I'm going to put a label there. As soon as I do a label, that label is actually going to help me to classify the clips on YouTube. That label is going to help me to classify the reviews of good, the reviews of bad. The ratings could potentially come in. So what is happening, a set of handwritten images and the corresponding machine readable translation as a training examples. This is exactly in the training set. As I'm going to talk to you about in a moment, in the machine learning, we have 3 sets. One set is called training set. One set is called test set. One set is called validation set. I don't want to leave my class without understanding that these 3 sets are different. In the training set, you are telling machine what to do. You're trying to train the computer what to do. So you're reading out loud, and the computer is going to read out loud. You're actually teaching the computer to read the same thing as you do. In the test set, you are going to see whether the training set has been successful or not. Now you are going to ask someone a question. After you teach them 20 questions and 20 answers, you want to ask them whether they remember the answer to one of the questions, right? So this happens usually in biology course, in some of the courses that you need to memorize. So you memorize, and then you ask your friend, your mom, your sister, your brother, and they are supposed to ask you the question. You give them the test bank, and you ask them, ask me. And when they ask you, that's your test phase. That is your testing set. And this is, if this is supposed to be basically supervised, obviously it's going to be clear cut. So the questions are not changing. You have 20 questions you need to train. You memorize. You give it to your mother. Your mother is going to ask you one of the questions randomly from the 20 questions that you have been seeing, and then you're going to answer the questions. It's supervised, okay? So you're trying to basically do that in a human interactions I was speaking about. You and your mother, okay? Or your father, your brother, your sister, your roommate. Now, in the test set, you want to see whether the training has been successful or not, or whether you need to do fine tuning. Very important for you to realize fine tuning is going to happen to the test set. Are we done with training? Not necessarily. Maybe when you do the test set, you're going to realize that fine tuning requires you to go back and do training in a different way. Maybe you forgot some of the parameters that you needed to consider in the training phase and you didn't. Maybe you have to do randomized sets for testing and training sets. Yes, but there is one big factor that you need to keep in mind. Your program is going to see the data on the training set and the test set. See the data on the training set and the test set. When you go to validation phase, you have never seen it before. That's the most important thing you need to keep in mind. If your machine algorithm is working perfectly in training set, no surprise, you're training the machine to do that. If the machine algorithm is doing fantastic job in the testing set, you will be very happy, 95%, 98%. What about your mother asking you a question from that 20 set of questions that I was talking about, and you forget the answer to one of them, right? So what happens? You got 19 questions right, and you got one question wrong. Make sense? So with that in mind, you're going to be still very happy. You're going to hear the question, you know the answer is wrong, you go back, you fix it. The next time your mother asks you the same question, you're going to answer that correctly. And the last one is a validation phase. In validation phase, the question is going to come at you and you have never seen it before. And it happens in the exam many times. Instructors would like to surprise the students with a question that they haven't discussed necessarily comprehensively inside the class. Simply, they want to know which of the students have been listening carefully, which of the students have been watching the material, so that they can say, okay, this student knows better, is well trained. This student is ready to take care of a question that is a surprise question. And it happens in life. Many things in life happens out of blue. And you need to be able to respond to those out of blue situations correctly. How? Training, proper testing, and a mixed bag of fine tuning and the selection of the test. Supervised learning, the 20 questions we have. The 20 questions you have, you put it on the table, you learn about it, and then you come back and say, what's the answer to this question? That's the supervised learning. Unsupervised learning is mainly, is actually quite hand in hand with clustering. Why? Because now you have a data set you have never seen before. Similar to what we discussed in the past, perhaps called it validation phase, but this is different. Even in the training phase, you don't know what to make of it. You don't know what the answer to the question is. And this is what a graduate program does to you. So for example, when you become a master's student or PhD student or a postdoctoral fellow or a researcher in a biological lab, COVID-19, you are dealing with something you haven't seen before. COVID-19, nobody knew. And then you're trying to say, okay, it seems to exhibit the signs and conditions of SARS, S-A-R-S. It's not SARS, it's a different virus, okay? So you need to basically start doing clustering. Even in the training phase, you must do clustering. And by the time you finish clustering, you want to test it. In the testing phase, you want to see whether you did it correctly or not. And then this is going to go on and on and on until your model is ready. What is the model? It's the brain in the algorithm that is supposed to do. And then I'm going to give you the validation set. And the validation set is brand new, out of blue. I'm going to give it to you, and you want to see whether your clustering that has come to become a model by itself, an algorithm by itself, is it going to do the job right or not? You do have the luxury of observing the training period. You have the luxury of observing the testing period. You don't have the luxury of observing the validation phase. The validation phase has never seen the data before. It's a very important, and I see quite often my students don't get this part correctly. The validation phase, you have never seen this data before. And this is very important when we go into overfitting scenario or underfitting scenario. It's very important for us to see. So a set of handwritten digits numbers, suppose that it finds 8 clusters of data corresponding to 1 to 8 digits. Since the training data are not labeled, semantic meaning of the clusters found by the mode is unknown for us. And when we say 1 and 8, people write 1 and 8 differently. I could write 1 and 8, it could be a little bit skewed, and you never know. 7 could potentially become 3. My handwriting may not be perfect, right? So you need to keep in mind, it's unsupervised. Meaning we don't have the basis point to judge. That's what it means. We can't give you the judging rule. If you go to the, when we talk about parking ticket, when we talk about a speeding ticket, that's a supervised environment. The rule is already set. You have already done that. The government has done it. It's perfectly, you're confined within the rule book. When we get to the unsupervised learning, you are the one who is going to make the rule book. And that's what the clustering is supposed to be, okay? Okay, and semi-supervised is that where you're going to utilize those that you have already labeled and those that are not labeled, and you want to basically see what you can do, how you can, what's the synergy between what you have already labeled and what is coming at you and it is not labeled. How do you want to actually mix and match and come to a conclusion in the scenario, supervised learning, okay? I want to give you an example here. So take a look at this one and see what it is. If I ask you to take a look at these pictures, what do you want to say? Okay, you're human. Again, remember, you need to be well aware at any moment in time, what's the difference between a human and a machine? If you can't distinguish that, you can't order the machine what to do. If you mistake a machine as in human, you're not working fine. You're not dealing with computer in the proper way. Now, take a look at these images. I would say this is possibly tiger. I'm going to say that this looks like a rabbit. I'm going to say that this looks like a horse, this one, okay? And this looks like a dog. Oh, this one like a zebra. You see what I mean? So take a look at this one. I'm going to say that this is, this looks like a dog. I'm just saying, I'm just making up some, this looks like a wolf. This is really similar to a wolf. I'm making this up simply, I want to alert you. Because if as a human, obviously you're going to identify everything as dogs in this one and everything as cats in this one. This one, I would say that this one is a black tiger. But again, I'm just teasing you because I want you to be alert to the fact that when you give this to a machine could potentially identify this as a black tiger because you have explained to the machine what the tiger is. You have also explained to the machine what a cat is, and there could be a misclassification sometime, and this could potentially become a black tiger. Classification is the process of finding a model or a function that describes and distinguishes data classes and concepts. So I want all of these to be dogs, and I'm sorry, I have to apologize. When I say I want, this is wrong. I want the machine to want that these are all dogs. I want the machine to basically classify all of these as cats. How? You need to have a function. You need to have a model. This model is used to predict the class label of objects with the class label is unknown. This one, potentially unknown. This one is a lion or lioness or lion cub that is sitting on. This one, we had a rabbit, this one, right? So we want, we may have some elements, some data that is coming at the computer and they have not been labeled in the past at all. Brand new data points. Now, here is an example. Now, I'm going to go and train the computer using programming, and I'm going to do the following. I'm going to actually help the computer and say, listen, as a human, I'm going to say all of these are camera. And I'm going to help the computer to understand that there is a roundness in many parts of these pictures, roundness here, you have a roundness here, you have a roundness here, this is a lens. Potentially you have a kind of a L shape that you could potentially have. I'm going to assist the computer to understand that this is going to be camera. I'm going to assist the computer to understand these images are the images of the computer. I'm going to assist the computer to understand that these images are the images of the cell phones, okay? After everything is said and done, I'm going to ask the computer to identify this. Do you find exact picture of this here, here, and here? No. But there are some similarities, especially the roundness. You can see the roundness. I do have a roundness here, but the placement of the roundness is not at the face, at the bottom. This is a kind of a roundness here. I could see a little bit of a roundness here, but I could help the computer to understand, for example, the physical location of the round circle in the image. And here I can see both a circle here and a circle here. As a computer, I can understand the circle. I can see the circle is the perimeter of a shape where it is going to be fixed radius from the center. So I can actually give the function to the computer, and the computer can actually understand the circle. So this one, what is it going to be? Is it a mobile? Is it going to be a computer? Is it going to be a camera? Very likely this is going to be classified as the camera. So we do have training phase, we have the testing phase, and we need to talk about validation phase. We will talk about validation phase in the later stage. There are many applications for classification. And basically classification is happening when you have enough data sets, enough data points. When we talked about this, I actually provided a lot of pictures as camera and computer and mobile. Much more, many more than what you see here. I actually provided with 1,000 here, 1,000 here, and 1,000 here, and then I was expecting this to be identified as a camera, okay? When you have enough data, vast amount of data, then the classification becomes relatively nice and successful because you're trying to cover whatever strange area that are happening. Remember the outlier we spoke of, remember the normal function, remember the two edges, the two tails. When you have so many data points, you are going to even be able to classify the tail of the normal function. Make sense? So customer target marketing, of course, I'm on Amazon. I'm the Amazon website, and I'm collecting the customer search. I'm going to collect the customer review and everything else. I have a huge database, and that database is potentially billions, millions, I would say hundreds of millions and potentially billions of people who bought from Amazon, and they left review and they left everything, footprints on Amazon. I could potentially take a look at the customer target marketing, and I'm going to say, I suggest to you what to buy next. Medical disease diagnosis, science has actually advanced to several stages of basically degrees of knowledge that I would say that you could potentially give us a rare disease in this today knowledge. You could potentially give me a rare disease, not me, the expert, and they actually would be able to identify what that disease is. Why that is possible? Because even if the disease has been identified by only 10 people across the globe, 8 billion people, and only 10 people have that a specific rare disease, the medical community has access to that data, and they know what the symptoms of that data is. They know what kind of tests that they need to do, and they would come back and tell you that this is the rarest disease happening, and only 10 people on planet Earth have that disease. Why? The database is very big, very large. Supervised event detection is actually quite self-explanatory, multimedia, biological, and document categorization and filtering. Yeah, if you are doing anything on cloud, if you're doing Google Doc, for example, if you're using OneDrive on Microsoft, if you're using any cloud of any kind, they have access to so many documents. And they can tell you even the template, they can send you templates. There are now tools available where they actually learn the document and assist you for law purposes. Lawyers are actually being replaced with artificial intelligence programs. Not all of the functionalities that they have, but some of the functionalities they have are being replaced. Social network, this is huge. WhatsApp, Twitter, iMessage, Facebook Messenger, and everything else. The data is coming and coming, and if you have the capacity to analyze them, you could easily classify. Is this going to be a threat to the society? If this person is going to pick up a gun and attack somebody, you could potentially, if you have the capacity to actually search and identify, you could potentially classify a very specific user or a specific tweet as a threat to the society. We can classify for different reasons. We have technique centers classification, we have data type centers, and you could potentially have a hybrid scenario where the data and technique are going to come in hand in hand to help you. Take a look at the fish. Let me show you the fish. This is a fish, and I want to show you the fish. It has, for example, different fins. You have the tail. I'm not an expert, so I'm actually I can't say different words, but obviously the kind of a wing, I would say, that they have is called fin, okay? So we have the fin, and also we have the lightness, we have the length. Length is obvious. Length is going to be from the head to the end of the fish. Lightness is going to be how it's about the color and the color intensity and the shape and the shape of the fin. So as you can see, this fin is different than this fin. It's different than this fin. So they are different, and you could potentially go and take a look at different types of fin, different types of terminologies. But what is the purpose of this slide? The purpose is this. I have studied so many fish. I have a database with 1 million fish inside. And I can tell you their length, I can tell you their color and the lightness, I can tell you their width, fins and shapes and everything else. I am a very meticulous person. And I'm going to actually go through all of these, and I'm going to give you a database, very accurate, very clean, 1 million of different types of fish. Can you classify? If you give me any fish, you went to Australia, you took a picture of something, I'm going to tell you whether it's going to be shark or not. Why? Because I have a database full of shark, and I can potentially match them against the database that I have. So classification usually works when you have extensive data points. That's going to be very helpful. Now, you could potentially start by representing the data points in the form of a 2D or 3D. In this case, this is a 3D lightness. Suppose that I have a unit to express the lightness, and then I have the width. Width is very easy. You are actually going to measure that. The lightness is actually does have the unit, and those who are studying the fish and other animals, they know what those units mean. Okay, so this is a collection of different types of fish. You can see that there are some reds and there are some blacks. And what happens, I could potentially come in and say, this is the line separating the top as in red and the black as in the bottom as in black. Okay, this is kind of a classifier. We talk about this classifier in different ways and different forms and different application and different reasons that we are going to utilize. But I want to bring something to you once more. Take a look at this side. You see a lot of red and you see a bunch of black. You see a lot of black and you see a bunch of red. This is called impurity. If everything was red on this side, and if everything was black on this side, that would be a pure division. So I want you to remember what purity means, okay? Now, we could potentially classify to the extent that it becomes basically perfect at the time of training, but it's going to miserably fail at the time of test, and even more so at the time of validation. So you see, these are the red, and I'm very obsessed by the fact that I want all of these red points to be one side, and I want all of these black points to be on the other side. I'm going to come in and actually classify them using basically this curvy line, and I seem to be very happy. I did it in the training phase. The computer, unfortunately, does not look and think like you do. But then you want to apply this to a test set. It's going to have a lot of impurities. Lots of black dots go into the red scene, and lots of the red dots go into the black scene, and it's not what you expect. So that's the problem with being obsessed with the classification and pushing the limit to 100%. That is why we don't want 100%. We don't want to be perfect in this scenario. I need you to be very careful about overfitting. When you do overfitting, you're actually killing the success rate. you are going to fail miserably in the test phase, and more so when the data set is never seen before in the validation phase. So don't overfit by any chance. And this is a case where I'm going to have kind of a trade-off between the type of line I want to have. Maybe I didn't want to have a straight line. Maybe I wanted to have just a parabola line. And the parabola line, perhaps I'm going to have better purity or lesser impurity on this side and lesser impurity on this side. It's not going to be perfect. I'm going to fail at some point. Just some of these, we would consider them outlier perhaps. And then still, the idea is, if you go through this process, you're going to be more satisfied in the test set when you want to apply that on the test set. And there are techniques that you can actually eliminate the obsession in the process. So you need to actually eliminate that. We call them, for example, leave N out, leave K out, or K fold and everything else. We will talk about them later. Another example, I want to label the items, the products that are coming at me. The products have a price, they have a place, they have a brand, they have a type. So the item features are there, but I'm going to say people have been reactive to those. How the product was received by the population? Good response, mild response, no response. So that's going to be the label I'm looking at. So I want to do this. But it would be very nice to eventually be able to maximally distinguish each class. Yes, 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 you're going to have impurity, but is it going to be 98% with impurity, 95% with impurity, or 99% or 100% with no impurity? So that's the challenge we face as the data scientist. There are different techniques. We are going to touch some of them actually in this lecture series. We have classification rules, we have decision tree, we have neural network, Bayesian and naive Bayesian classification. Very briefly, one slide or two on SVM, and then the KNN we have spoken of in the past. So I want to go through them in near term. The beauty of regression, we have spoken in the past of regression. We are going to again talk about regression techniques in this series, is used to predict missing or unavailable numerical data values rather than discrete class labels. So if there's something that is missing, and we are talking about the boundaries. So the boundaries is, for example, 0 to 10, and then from 40 to 80, the data points are in our possession. We already know the maximum, minimum of each one of them, and then and then that's how we want to do it. Okay. I had to put the battery in so that the recording doesn't stop. What is happening? It is a data set. You have the maximum, minimum of all the dimensions, and then there is a point that is missing, and you want to interpolate. So this regression technique can help you to find. So if you have a line, if you have identified the trend, you could potentially tell me what the value is supposed to be around this line, with some standard deviation, by the way. So you can say this is my center point, this is my center line, and you can say that the standard deviation around it, you could potentially tag it to the probability function, and then you can say this is what's going to happen on this this area. So you could either predict numerically, or you can predict the class label. We talk about that in the future. And regression also contains the identification of distribution trends based on the available data. So you're going to get in and out of the data, and you're going to identify a missing point. Remember, this may not be the same as what we are talking about, the prediction. At some point, the prediction, you might want to predict 11, x-axis 11, x-axis 12. So that would be something we call extrapolation. Here we want to actually label them. We don't know what the label of each of the points in the data set is going to be. So label, this is also considered prediction. We need to get used to the word prediction and what it means in this class. this is a simple example. We understand that what the prediction means. That means a future. Predict the amount of revenue that each item will generate during an upcoming sale at a digital appliance store based on the previous sales data. What does that mean? It's outside of my time zone, but inside of my data set. It's time zone outside, but inside my data set. I already know who are actually my member. Costco has memberships. Sam has memberships. You go in, even Walmart has can potentially analyze your purchasing pattern using your credit card that you're using inside the Walmart. The Walmart has, I believe they have their own reward card or something. So basically they can potentially analyze. It may not be perfect, but as long as you use them, they have access to the data and they can analyze. So what are we trying to do? We are still within the boundaries, but we want to know the future. So the regression model constructed will predict a continuous function or an ordered value for the future. How? Using the boundaries we have. Are you going to come into Walmart and buy an airplane? No, it's very unlikely you're going to buy an airplane inside the Walmart. But obviously you're going to go there and you're going to buy groceries and you're going to buy some necessities in kitchenware and everything else. Everything is perfectly known. And I have already seen the patterns of many customers coming to Walmart, Amazon, Costco, Sam's, and then I would be able to predict what happens. Now, if I want to populate my shelf, I'm going to populate with items that are going to be sold in this particular region, in this particular branch, in this particular store. I'm going to populate them more and more because that's going to be related to my revenue, okay? So that's the kind of a regression analysis. Clustering is different. Clustering is completely different from classification. Of course, they are going to work together hand in hand, so they are not going to be isolated, basically concepts. They are different concepts, but they are working together collaboratively. Now, in the clustering, as we have spoken, unsupervised learning technique, you want to see where these items are going to be, where these items are going to be, where these items are going to be. And the way you're going to do that, let's be human for a moment. The way you're going to do that is that this is a trapezoid, trapezoid, trapezoid. You want all of these to look like a trapezoid. This is a plus, plus, plus with some boundary red. You want all of them to look like the same. But there is a huge difference between trapezoid and this one. So if you were a human, and the reason you can do this very fast, you're going to say all of these are supposed to be similar or extremely similar or perfect match. And all of these are supposed to be similar and extremely similar or a perfect match. At the same time, you want these two to be as dissimilar as possible. As dissimilar as possible. You're trying to separate, you're trying to cluster them. Now, as soon as you succeed in the training phase, the computer needs to learn the rule by itself. How? These are trapezoid. The shape has to be somehow, by the way, when we say the computer needs to learn the rules, the way the computer learns the rule is given by you. You are the human, although we call it unsupervised learning. Keep in mind that it is you who are doing the coding. And eventually the result is going to be based on the coding that you wrote that is going to actually come around and say all of the trapezoids are supposed to be here, all of the pluses are supposed to be here, and all of the stars are supposed to be here. Now, if we do perfect clustering, we call this pure, pure and pure. What if there is a trapezoid here? That's impurity. What is there is going to be a trapezoid here? Impurity. And what is there is going to be a star here? Impurity. We don't want impurity to be high. We want this to be as pure as it can get. We want to maximize the intra-class similarities, all of them trapezoid, and we want to minimize the inter-class similarities. We don't want these two to be similar, these two separate classes. Identifying homogeneous subpopulations of customers in a digital appliance store. These clusters can represent individual target groups for marketing. You could potentially look at the income if they have provided it to you. You could potentially take a look at the history. They have been purchasing expensive items from you. And you can potentially project that these type of people who come in and to your store, they are going to buy another series of products that are going to be expensive, high-class components, good brand, best brand in the market. Those are the type of people, because you can see in their history that they have been buying based on brands, not based on the price. At the same time, I'm a student, I want to go to a store. All I need is to meet my regular need. I don't need brands. I just need my life to be safe. And I want to just buy because my budget is limited. So I'm a price, there is a price tag on me. So in that sense, there is a tag on me saying, this is I am a student, and the student doesn't want to go and buy a TV. Why the student wants to buy a TV $4,000? Unless you have had a pattern like that, buying expensive items, there is no reason for me as the store owner to assume that you are going to buy a $4,000 TV, right? Or perhaps according to the locations in the city, because there are some stores, not all of them, that actually they ask you to enter the postal code. So when you enter the postal code, they actually tag you with the geographic location you're in. Let's take a look at this. I'm going to continue this and I'm going to close this in a moment. The way we are going to do it, we have a training data, we have a classification algorithm, we are going to identify the classification rules, we are going to apply that to the test set, and then we are going to see the new data. I'm not sure how many is left. Yeah, there are 2 more left. So I'm going to continue and finish this, and then I'll go to part number 2. Take a look at this data. If you take a look at this data, what do you see? You have sample ID. That is nothing to me. It's just a number, bunch of number. There is no identifier. Unless you want to build a database, then the identifier is very important. When I say 4, I mean all of this. When I say 8, I mean in the database management, we teach of that. When I say 8, I mean all of these. So all of the row is going to be ID'd by the sample ID. But having said that, you take a look at the color, you take a look at the size, you could take a look at the act, the age, and the inflated. Doesn't matter what inflated is referring to. Now, this is my training data, and then I'm going to come back and say, if the color is yellow and the size is a small, what happens? The model, yellow and a small, true. Yellow and a small, true. I don't have yellow and a small anyway, and that's going to be, obviously, my conclusion is going to be true. I simply train my classifier now. I said, if you find yellow and a small, based on available data, which could be millions or billions of rows, I'm going to tell you that it is true in inflation. But imagine that I want to have a new data. Take a look at this. And I want you to listen carefully to this last slide of part 1. And that is, this is yellow, this is size, act, age, and inflated. I'm going to do this, I'm going to actually try that. And I had this is as my testing data. And then I'm going to do a new data. Remember, this is the validation phase we are talking about. The data has never been seen by your algorithm, never. Take a look at this. You have a yellow, sure, I have a yellow. Then you have a large, I do have a large. Then I have a DIP, I don't have a DIP. Then I have an adult, I don't have an adult. But the question is, the data is brand new, you have done testing, you have done training, so you have this, for example, once again, if I'm not mistaken, yellow, large, dip, DIP, adult. Yellow, large, I don't have dip, yellow, large, dip, and adult. In this case, I should have said F anyway, if this is the case. But I intended to give you a case that is not in my system. So this is supposed to be, let's say that this is yellow, large, dip, and children. Okay, that's good. So let's say this is yellow, large, dip, or say already have it. I wanted to have a data that is not seen, and that's what I mean. When the data set becomes large, this becomes quite easy to classify. But imagine that I want to have yellow, and I want to have purple, large, deep, and paper, large, deep, and adult. I'm going to be purple, and child. I think it might work. It doesn't, because the data is so big that I have captured that possibility. Of course, I'm trying to make a case. Imagine that this has not been seen before. It's really important for us, even through my own mistake today, I want you to imagine that I'm insisting that the data has not been seen before. If it has been seen before, it's very easy. You simply go through the table, you do a sort, you do a search, you find it, and that's the outcome. What if this data has never been seen before? The way you're going to do that, suppose that this is your training and test set at the same time, just for the sake of my argument, so that I can feel peace at this recording. Suppose that this is your training and testing at the same time. Yellow, large, dip, adult. Yellow, large, I don't have a dip, I have child. Yellow, a small, deep, adult, I don't have a large. And there is a large and deep adult, but it is purple, not yellow. So for my sake, please assume that this is a training set and this is a test set at the same time. And then this data has not been seen before. You can see it is a smaller data set. And of course, the chance is that it has not happened before. Now, but you're going to make a decision now. You're going to sit down and say, whenever I had large, take a look at this. Again, assuming that this is a standalone slide by itself, this is a large. And whenever I had large, I had F. Okay. When I had yellow, I had true and false, 50-50. When I had large, I had 100% F, 100% F. When I had DIP, I had 2 F's and 1 T, false and 1 T. So if I say deep, I could potentially be leaning toward F. When I talk about adult, I'm 50-50 between T and F. Now, if you take a look at this, what is the weight? Where is the weight leading you to? You say large, 100%. Then you are going to say deep is going to be 2/3, 66%. And yellow, 50%. Adult, 50%. Apparently, the entire solution is actually directing you that this must be F. You have not seen this data set in the slide, and I ask you to remain in this slide, and you have not seen this data set, but you can tell me what is this going to be. That's going to be F. That's going to be a false alert. In the next session, we are going to talk about the significance of the color, the significance of the size, the significance of that. Right now, you can say that having a large is going to yield a very easy outcome, F, because all the large incidences have actually come to be F. So if I have large, possibly it's F. I didn't even look at the color, I didn't look at the age, I didn't look at the act. I just said large is going to be significant. That's done, finished. So this is going to be F. I could say the dip itself is going to help me to make that decision. So perhaps after the size, I'm going to focus on act. And DIP, I would say DIP child, DIP adult. I'm going to say this is perhaps FF and then T. I didn't even say age here. I just said act. If I brought the age, that would be different. Deep adult, you have 50-50. But I didn't say age. I just simply said act. And then therefore, this is going to be 2/3. So after the size, I'm going to put act inside. And after that, whether color or age, that would be my secondary, my third stage decision to make. I want you to feel the topic so that when we go and make it a little bit more technical, you feel at home with the topic. Okay. Thank you very much. Stay tuned. There will be upcoming recordings shortly.